For Criterion C, ideation and modeling, there are two strands for this. C1 is presents feasible redesign ideas, and C2 is identify the redesign ideas. Okay, so looking at the rubric here, the 5 to 6 marks for C1 presents 3 of the best possible annotated feasible redesign ideas to address the problem statement and all key features. And then for C2, it evaluates the redesign ideas against the design specifications through the testing and user feedback. So when we're looking at this here for the command terms, this is a kind of a tricky one for C1. They're all present, but your iteration and your annotations will play a big factor in this. So you really want to be, I suppose, looking at the describe and justify for your annotations. And then you have got evaluates, describe, and states for your C2 command terms. So this is out of 6 marks. You have got 8 pages and you've got 900 words for this section, for this criterion. Okay, so for Criterion C, what you've basically got to do is present a range of annotated feasible redesign ideas using the appropriate mediums to address the problem statement, which can be interpreted by others. And then for C2, you've got to evaluate the redesign against the design spec through testing and user feedback. So for C1, if we look at the rubric, it does state that we just have to present 3 of the best possible annotated designs. So looking at this, what it's asking you to do is come up with sketches. You can have CAD, drawings, fidelity models, 1 to 2 A4 pages per idea. And then you've got to highlight the additional, any bit of extra research that you might have done. So you might have explored perhaps material research, component research, manufacturing techniques, for example. And then this would enabling iterative development of ideas. So you've got 6 pages for this. So if you're doing 3 designs, for example, that's going to be 2 pages each. But you need to really kind of go to town on the design, the development, and ultimately trying to come up with a high fidelity, basically a working prototype essentially for this. And that all needs to be within the 2 pages. Then for C2, you've got to identify the redesign ideas, so evaluate the redesign against the design spec through testing and user feedback. So this is constant throughout Criterion C. What you've got to do here is an annotated presentation of drawings and feasible redesign ideas tested against the design spec and user feedback. So you've got 2 pages for this. So basically, I've merged C1 and C2 together because they should kind of, the whole Criterion C, you shouldn't really see like a dramatic end for C1 and then a start of C2. These 2 criterions really should be blended together. So that's why I've done one recording for this. I had a recording for C1, but I've deleted it because C1 and C2 really need to be blended together. So in simple terms, what you've got to do is you've got to show the ideation and modeling process. So you've got to come up with, initially, I recommend that you come up with maybe 8 to 10 designs, and then from that, whittle it down to maybe 3. Now, you don't necessarily need to evidence this on your IA. You can if you wish, but ultimately you need 3 designs and really go to focus in on those. So you need to just, I'm not going to read this whole thing, but just focus on some of it. So physical fidelity modeling. So, you know, this is just kind of like your card and foam models. So you will have low fidelity modeling and high fidelity modeling. And we kind of cover this here in the modeling section here. So low fidelity models are used to test the general principles of an idea. So you're figuring out the size, maybe the ergonomic features in it and whatnot. And then highly accurate fidelity models mimic the real product. So like you might 3D print something, you know, trying to get a working prototype. That's the high fidelity models. You're always going to be testing against your design specs. So your annotations will constantly link back, and you will have tables in your work to make sure you're linking it back to your specification. Your designs must address the key opportunities identified. So you need to be kind of looking at the persona and your task analysis, making sure that you're actually addressing what you initially set out to do. And then moving on, selecting the most appropriate ideas should be validated against the performance and user requirements. So you really need to be designing something, modeling something, getting feedback, refining it, getting feedback, and then perhaps coming up with a final working prototype from that. So you need to evaluate and test based on design specs and feedback from the intended users, as I've just said. So you're constantly going through that process. So just looking at this here, ultimately this is a design portfolio, your IA. So you need to make sure that you take a bit of pride in the presentation of your work. I always say a good 2D sketch is better than a badly drawn 3D. So there's various different things that you can do. Just like a fine liner along the outside can really help, a bit of shading and whatnot. Once you create your initial design, I would scan it. Okay, the scanning app's on your phone, you can scan it out a photocopy and whatnot. Make sure that you've got a copy of it. And then you can apply the shading and whatnot, so that if you do make a mistake with the shading or rendering or coloring in, you've got a copy of it. So this box here behind this color block, and this really helps your design work stand out. So it's important that you incorporate these into your design work. So as you can see here, these designs on the right, they're probably drawn on, I'd imagine, maybe Procreate. It's a really good app. So as you can see, these designs here are all 2D. They're all drawn in 2D, but the shading really makes them stand out, and they nearly give the appearance of 3D, but they're actually all drawn in 2D. So that shows you the importance of just how effective a bit of shading and rendering can be. And then the color block really enhances it, really makes it stand out. See these kind of like construction lines here? It's important to, you don't necessarily have to rub them out. Like it's good to show how the object was drawn as well. So it doesn't have to be everything rubbed out, but just going over the outline of items here, applying lines to show different surfaces and whatnot, really makes your design work stand out. So if you look at Pinterest, for example, there's loads of examples that can give you inspiration there. So when it comes to design work, as you're developing your design, so it's important to think about how you can improve it. So one useful method is Scamper, and your teacher can kind of go through that with you. Basically, you've got a substitute you combine, adapt, modify, put to another use, eliminate, and reverse. So if we look at this chair example here, a previous colleague of mine designed this as an example. It's a really good one to use. So this example of a chair, you combine, join the two together, adapt, and put to another use. So a bit of storage unit here, create an angular piece here. For the modify, rounded the edges, eliminate, got rid of the centerpiece here, so it might be maybe lighter to move, and then reverse, it might be used as a stand-up desk here, and as well as being able to sit on it. So when you come to your design, it's important that you try and enhance it and develop it in many different ways. And then here on the right, we can see the importance of using proper rendering pens, so they can really enhance just a bit of shadowing here, and different colors on the surfaces and whatnot can really make your design work stand out. So some examples on YouTube, some channels that you can follow. Simply Design Sketching is an excellent one to follow, and I highly recommend that you do. Great videos on ideation and just creating initial ideas and how to develop them and present your work. It's an absolute quality page. I recommend you follow it. And then this page here, Roberts has a really good one on biomimicry that's worth a watch. And the Sketch a Day, the Design Sketchbook, and Scott Robertson are also really good ones to have a look at as well. Okay, so there's no shortage of resources online to help you with your design work. So if we look at the first example, so this here is C1, the prosthetics example. So as we look through this got a grade 6 out of 6. So they come up with 5 ideas. Annotations highlighted the strengths and weaknesses and user feedback. So we've got the user feedback here. This is compared against the spec. So I feel that that's maybe a bit generous, given this is 6 out of 6. I do think there's maybe some aspects of it that it didn't address. And then this moves on to C2. So your design work should really flow. You've got essentially 8 pages for Criterion C. So you should be able to see, right, this format here, they haven't followed the typical one of 2 pages per design and whatnot. They came up with a range of designs here, 5 designs. You only really need to come up with 3, and then they whittled it down to 1. You can, I guess, do that. I wouldn't personally recommend it. It depends on the context of your design and what your IA is. Your teacher will be able to give you guidance on that. So they whittled it down to 1 and really focused in on 1 here. Note that your annotations here are 10 words or less. You can have bigger annotations here because you do have 900 words. So you can use a bit more for that. But I recommend not having 900 words just as a big, massive essay. It should be broken up into sections throughout your whole Criterion C. So your design work, the main thing here is that it should flow. For this particular example here, personally, I really struggle to make out what that is here, up in the top right. Like I can see this design, and this design here, but these 1 or 2 here, I really struggle to figure out what they are. So just some suggestions for this one here. Remove the text box. It makes your design work look very boxy. It looks horrendous in my opinion, but if these boxes were removed, the presentation of the work would be significantly better. Note that this is color coded here, and these points here, like 2.1, 2.3, they will link back to the specification point, which was made by the student. So note that the work here, you can see kind of 2D sketches, 3D sketches, and you can see how it's kind of flowing, essentially. So these bits here mimic this bit here. So your design work essentially should flow, really. Another thing here is just labeling your designs: design 1, design 2, design 3. This is the fourth design. So this is what I really struggle with, this one. And this is design 5 here, I guess. From the old syllabus, we had design, model, test, evaluate, and refine. I don't necessarily agree with the circular motion of this. I feel it's more of a spiral visual that we should be working towards, where we've got design, model, test, feedback, refine, design, model, ultimately until you come up with a finer working prototype. And by doing that, you will go through the low fidelity to high fidelity modeling. So if I look at this example here, this one got a grade 5 for C1, presented 3 ideas, strengths and weaknesses, and some user feedback. So this here, testing here, so this one here was based around a trowel, but this sort of testing here, I wouldn't really recommend it. This is low fidelity modeling here. So if this was actually tested with the product, in the garden, and have evidence of it actually being tested in real life, that would dramatically enhance the user feedback for it. Presented 3 ideas with annotations, strengths and weaknesses, and there's also evidence of physical modeling, user testing. Again, I think grade 5 here is quite generous for this particular one. The improvements can involve the inclusion of further research to enable iterative development of each idea, which was not apparent. An additional idea to investigate would have also been useful. Although they did 3, they were suggesting that you should have done another one. So that will all depend on, you should use up the 8 pages that you have for the section. This is the page where you really get to show off your design capabilities. So again, here with this one's probably a bit more, similar amount of modeling here. What they could have done to improve this particular example, the positives are it's 3D model and sketches, it's legible annotations with lines, they're not arrows, so use lines, please. It's rendered and colored, so it just makes it stand out a bit more. There's low fidelity modeling done, and there are also measurements on the design work. Suggestions: text is inconsistent. Some text seems smaller than others, and it's not really legible. Label the designs, so design 1, 2, and 3. There is, I suppose it is there. A feedback loop of design, model, test, feedback, and refine isn't really evident. So, it should flow perhaps a little better. So the modeling, a range of ergonomics handles leading to a 3D printed outcome. So that would be kind of your high fidelity. So for example, in figure X, they could have modeled these in foam and then 3D printed them, and then they would be your high fidelity models. So that would have really enhanced this example. If I was grading this particular one, I probably would have given it a 4 out of 6. I don't believe it's necessarily top band. I just feel it's not really hitting the high fidelity model part. So for C2, for this particular part, for C2, it got a grade 4. The student provided a simplistic, anecdotal, and numerical evaluation of each idea, along with a brief comparison. There's room for improvements. A more detailed evaluation incorporating performance, user requirements, and feedback against specification would have enhanced the analysis. Additionally, a clear summary identifying the selected idea is essential, particularly considering the superficial nature of the student's work due to the absence of actual testing and testing in situ. So, having it in its environment being tested is quite important. Testing it in the workshop or in your classroom is not really adequate. It needs to be tested by the user in the environment, like where they're conducting the task analysis, linking it back to Criterion A. It was interesting here, the mention of a summary. So you have got 900 words, but I feel that the 900 words should be distributed throughout Criterion C, as I've mentioned earlier. And this was the remaining of that one there. So as you can see, they don't really go near the 900 words for this particular example. If they have half of it, that would be about it. So these ones here for C1, this particular example, the wheelchair disability desk, the example 2 from IB. The student actually got penalized because they explored too many designs. They should only really have looked at 3. The second idea fails to address the issue. It wasn't really resolving the initial problem. The low fidelity card modeling is evident, but the student could have emphasized additional research and feedback during the ideation phase, and it needed more user testing. Now, this design here got a grade 4 for C1 and C2. The design work for this one, as you can see, the presentation is really good. Quite like the lines here and how it's presented. Got good knowledge here with your finger joints and dowel joints drawn in perhaps isometric, so it's presented really well. Perhaps maybe a bit more detail in the annotations would have been good. Maybe a bit more justification would have been better. It could have, looking at the feedback here, it could have got further research gathering feedback from experts and clients. So incorporating the feedback would have facilitated additional iterations, enhancing the overall quality of the design. So they don't, basically what they're saying is they don't want you just to design something, create a CAD, and then that's it. You need to sketch, model, maybe a bit of CAD, the whole thing should kind of be interwoven. You test it, get feedback, redesign it, test it again, and then come up with a final design. This example here, example 5, the FPV drone racing tool. There were no apparent modifications addressing the user needs, so this got upgrade 2 overall. And the improvements by aligning the redesign more closely with the identified user needs. So they didn't actually really do what they set out to do. So looking at C2, we have, in this example, example 2, the wheelchair disability one, it got a grade 3 for C2. So as you can see here, they've compared it a bit more against the spec, although they use a simplistic numerical representation. There's limited analysis of the selected ideas. The justification for the chosen ideas is also simplistic. Moreover, there's a 900-word count limit for this aspect. The students should have provided more elaborate explanations of the differences between the ideas against the design specifications through testing and feedback. So testing, user testing, you can be, ultimately this is in a group 4, so it is in the sciences. So you can, conduct material experiments and manufacturing experiments, what is the best item to make a certain part and whatnot. These are all things that you can do. What components, why are you using a normal nut and bolt? Would a wing nut perhaps be more efficient or easier for a user to take off than a standard hexagonal nut? So all these little things are really good things to experiment. Looking at this example here, it's got a grade 4. User and expert feedback. However, there was a missed opportunity to provide extended text outlining user and expert feedback. So let's say, for example, if you're making something for a dog and whatnot, bringing it to getting a vet's opinion or something like that would be classed as an expert feedback. So anything like that would really help you. It remains unclear which idea was actually chosen in this math example here. And then the FPV, this got a 2. It's simplistic comparison. These are all statements here, lacking relevant testing evidence and feedback. Notice the word stating here is in bold, so these are just all statements. Further referenced to the design specification and conducting testing with relevant feedback to support the comparison. So the 900 words should not just be used in C2, it should be incorporated into C1 as well. And you're constantly, looking at and comparing yours to the task analysis, the specification, and the user's needs. So this is a checklist here for C1. I'm not going to read it. The Google slide is available, so you can go through that. Checklist for C2. Note that it would be important to include a little perhaps summary at the end of your C2. Just make sure you're specifying what design you're looking at, you're taking forward into Criterion D. So these are question prompts for your annotations. So these can be your annotation point. I've put the syllabus link here in brackets because I feel it's important that subconsciously you mightn't realize it, but you're actually covering a lot of the syllabus just by doing your IA. And all these are question prompts. Obviously, if they're not applicable, you don't include them, but these are all different items that you can include into your annotations. And I would strongly recommend having a look at these for your IA. But ultimately, just quickly recapping, the main thing is to make sure that your design work flows. So notice how on this example here, this is the 4th page, the evaluation, basically your C2 for this one was on the 3rd page. It should be incorporated, it should be embedded into your Criterion C. Come up with your designs, try and make an actual prototype for each, a proper, let's say 3D printed or using whatever tools you have available to you to make a working prototype. By the end of Criterion C1, you should have 3 prototypes. That way then you can test them, the user can test them throughout C1 as well, and then you can establish which one is the best one to take forward and why. So for example, if you had 3 that were fully developed, like this one here, you could really go to town on the 900 words. You could really do deep analysis on which one is the best one to take forward and why. And there's loads of different experiments you can do with regards to materials, components, manufacturing techniques, user feedback or ergonomic features and whatnot with regards your redesign.